So dy dx will be equals to a negative of, you differentiate x squared, you get 2x. Then you differentiate a constant, you get 0, divided by, you differentiate a constant, you get 0, plus you differentiate y squared, you will get 2y. When you simplify, you will get a negative x over y, and that's it. Hey guys, welcome to eMath. Today I'm going to show you a shortcut for implicit differentiation. First of all, let us differentiate this implicitly using the conventional method. So conventionally, we'll use like d dx of x squared plus d dx of y squared equals to 0. Then this will be a 2x using power rule, plus this will be a chain rule, and which is 2y multiplied by a derivative of the inside function, which is d dx of y equals to 0. Then it will be a 2x plus 2y dy dx equals to 0. Then next we try to express dy dx in terms of x and y, which will be a dy dx is equals to negative 2x over 2y. Then simplify it, we'll have a negative x over y. So this is how we differentiate implicitly. But today I want you to focus on this step. Okay, so if you have a look, this 2x is actually the derivative of x squared, right? Then this 2y is the derivative with respect to y of y squared. And this dy dx is just like the y prime, okay, y prime, then plus equals to 0. Yeah? Okay, now the question is, how do we relate this step back to the equation? Okay, so okay, if the y here, if y is a constant, then when we try to find the derivative of it, okay, we differentiate it with respect to x, it will be a 2x plus with a 0, which is 2x, and it is the same as this part, isn't it? Then on the other hand, if x is a constant, then same thing, I will differentiate it with respect to y, then we will get a 0 plus 2y, which is 2y, and this is the same as this part. The truth is, this step here is actually a partial f partial x plus partial f partial y times dy dx, and it is equals to 0. I'll explain about the partial derivative later. Okay, and we can write this as fx plus fy times dy dx equals to 0. And remember, we want to get dy dx, right? So we will try to rearrange it, and we have dy dx equals to negative fx over fy. And this is the shortcut that we will use today. Okay, so to understand how it works, we need some concept from Calc 3. Okay, we need one concept from Calc 3, which is partial derivative. So what is partial derivative? By definition, okay, we always start with definition. Then for a function fxy, which means this is a multi-variable function. Of course, I will try to keep my explanation in single variable. Okay, anyway, for multi-variable function is like something like we have a z equals to like f of x, y, which means it is the value of z depends on x and y. Like example, x squared plus y squared plus 2xy cubed plus 2x to the 4y, something like this. Okay, so for function f, the partial derivative of it with respect to x at x naught, y naught is given by the limit when h approach 0 of f of x naught plus h y naught minus f of x naught y naught, then over a h. And what is the meaning of this? This means we differentiate with respect to x for this function f x y naught. at the particular point x equals to x naught. Yeah. So in this case, we are taking this y naught as a constant. Yeah, this is what basically what we did at the beginning, right? So similarly, partial f partial y at x naught y naught will be equals to the limit when h approaches 0 f of x naught y naught plus h minus f of x naught y naught over h. And similarly, this means we differentiate with respect to y for this function f x naught y at y equals to y naught. And in this case, x naught is a constant. Yeah. So this is a definition for partial derivative, and I think this is all we need for now. Okay, now let's talk about chain rule, the most important rule in calculus. Okay, let's start with a very simple example. Okay, maybe a u equals to f of x and x equals to g of t. And in this case, we will let u be a differentiable function of x. And similarly, we let x be a differentiable function of t. Yeah. So let's say if I want to find du dt, what we usually do is we take du dx multiply with dx dt, so that dx and dx can cancel, then we'll get a du over dt, right? Then how does it look like on the dependency diagram? Dependency diagram. So we'll start with u. Okay, and this u is what we call a dependent variable. Okay, dependent variable, which means the value of u depends on x and x depends on t. Okay, so I will write a x in the middle, and this is what we call a intermediate variable. Okay, why? Because the final derivative that we want is with respect to t. So x will just be an intermediate variable. Then how do we get from u to x? Is to take the derivative du dx. Simple. Then from x to t, which is our independent variable, we just take dx dt. And from u to t, we just need to multiply both of them. Yeah, so this is for simple chain rule. Then what about for multivariable? Like if we have a u equals to f x y, we just can't have a very simple one line, right? So what we do in multivariable calculus is we split this into two, okay, x and y. But we cannot differentiate the whole thing with respect to x directly, right? Because we still have another variable which is y. So the only thing we can do here is to take the partial derivative. So it is a partial u, partial x. And for y, we'll have a partial u, partial x. So like temporarily we are treating y as a constant. And for this part here, temporarily we are treating x as a constant. And after this step, we want to get in terms of t, right? Okay. For this case, we can directly use dx dt because we only have like from x directly to t, we don't have another variable, so we can directly use dx dt. Similarly, from here to here, we can directly use dy dt. Okay, so in this case, du dt will be this plus this, which is partial u, partial x times, remember when it is in one line, we use multiply, dx dt, then plus with this part here, which is partial u, partial y times dy dt. And this is how we involve partial derivative in chain rule. And of course, if we have like more intermediate variable, like maybe one more here, one more there, we just keep on adding to the end. Yeah? Okay, the next question is, can we apply this in single variable? The answer is yes, but with a condition. Like if we have a u is f of x, y, yeah, this must be equals to 0. Why? Because if u equals to 0, then when we differentiate it in terms with respect to maybe x, okay, why? Because usually x is the final independent variable that we want, right? So du dx will be equals to 0. Okay, now since our final independent variable is x, we just need to change all the t here to x. Yeah, so we change this to x. This will be a x. This will be x. This will be x. This will be a x. Then this will be a x, and we are done. So du dx, okay, which is the whole thing here. Let me copy it here. Will be partial u partial x times, okay, dx basically means dx of x, which is equals to 1. So we multiply by 1, very important, plus partial u partial y times dy dx equals to 0. And this is what we have at the beginning, isn't it? Okay, now this is still very complicated, right? So I will use fx to represent partial u partial x, and fy to represent partial u partial y. Okay, so we have fx plus fy dy dx equals to 0. Rearrange it, we have dy dx equals to negative fx over fy, and this is what we want. Okay, now we are trying some examples. I put down the conventional method for your reference and to compare. Yeah. So first step, we try to arrange everything on one side so that we will have a 0 on right hand side, right? So it will be x squared y plus xy squared minus 6 equals to 0. This means f of xy is equals to 0. And now we can do the shortcut. Okay, so dy dx will be equals to, remember the negative, yeah? And this is a fraction. X squared y, it is 2x, and y in this case is a constant. Yeah? Then plus with x you differentiate becomes a 1, then y squared is a constant, so it's a y squared. You differentiate a constant, you get 0. Yeah, and that's it. Then for denominator, we will differentiate with respect to y. So this time, x squared will be the constant, then plus with 2y, then x is a constant, minus, this will become 0. Then you simplify it, we'll have you distribute the negative inside, we have a negative 2xy minus y squared over x squared plus 2xy, and that's it. See, it's the same, isn't it? Example 2, now we have triangles, but same thing, we'll try to make this to one side. 1 over y minus 1 plus xy equals to 0, so that fxy is equals to 0. And dy dx will be equals to, always remember the negative, yeah? And this is a quotient. Okay, you differentiate with respect to x, the whole thing here will be a constant, which is 0. Minus, still a constant, 0. Plus, okay, this will become 1, and y is a constant. Then for denominator, this is slightly more complicated. We still have chain rule and we have product rule, but never mind. It will be we differentiate with respect to y. So first is a product rule. Okay, y cos 1 over y negative 1 over y squared. Yeah, we don't have to write dy dx again like this because it is the same variable. Then plus with sine 1 over y times 1. Then minus 0 for constant plus the constant now is x. Then we just try to simplify this. It will be a negative. Yeah, we try to bring a negative to the top. Y over this and that can cancel. Negative 1 over y cos 1 over y plus sine 1 over y plus x, and that's it. Okay, just want to share some thoughts with you as a math student. So a lot of time, what you learn in advanced topic can actually help you to solve your nightmare in the past. So keep on learning, and that's all for today. Thanks for watching.